Hello students, this video is part 5 on motion in a straight line. In this video also we are going to see NCERT solutions. This is your first question students. Two towns A and B are connected by a regular bus service with the bus leaving in either direction every t minutes. A man cycling with a speed of 20 km per hour in the direction of A to B. So what is the speed of this man? 20 km per hour. Is that right? Okay. In the direction from A to B, from town A to B. And he notices that a bus goes past him every 18 minutes in the direction of his motion. Right? So what he observed in every 18 minutes, he is observing a bus which is passing him in the direction of his motion, and every 6 minutes in the opposite direction. Okay, so this is the frequency of the bus. Okay, so in his direction of motion he is observing a bus in every 18 minutes, and in opposite direction he is observing in every 6 minutes. Okay, right. So this is your given data. What is the period T of the bus service, and with what speed do the buses ply on the road? Okay, so hope you understand this question, right? So if V is the velocity of the bus, see, this is the thing we should calculate, right? So what is the period T of the bus service and what is the speed of the bus? These two things we have to calculate in this question. So we take V as the velocity of the bus, then the distance traveled by the bus with relative velocity of V minus 20. What is this? See, both the bus and the man is traveling from A to B, right? So both are traveling in the same direction, means we should take a difference between the two velocities, isn't it? So V minus 20 in 18 minutes, right, is equal to the distance traveled by the bus with relative velocity of, so in both the directions the speed of the bus is considered assumed to be constant. Okay, this is also given in the question. So in both the directions the velocity of the bus is assumed constant, right? So what we are taking, V minus 20. So this 20 is nothing but the velocity of the man. Okay, the speed of the man, 20 km per hour. He is traveling from town A to B. Okay, so V minus 20 in 18 minutes is equal to the distance traveled by the bus with the relative velocity V plus 20. Why I am taking V plus 20? Okay, so look at the direction of the bus in opposite direction. Okay, so this is towards town A and he is traveling towards town B. So both are in opposite direction. So the velocities to be added. So V plus 20 in 6 minutes. Is that clear? So we should equate both the things. So we are taking, as per the question, we are considering the velocity of the bus is constant. Okay. So we are equating both the things. So V minus 20 into 18 divided by 60. What is this 18 divided by 60? We are converting 18 minutes into hour. Okay. So V minus 20 into 18 divided by 60 is equal to V plus 20 into 6 divided by 60. Okay, so what you will get, V equal to 40 km per hour. See, this is the velocity of the bus, 40 km per hour. We have calculated the speed of the bus. And next thing, what we need to calculate, time period. Okay, time period of the bus service. This is your second subdivision. Okay, the time interval between the two meetings of the man to the buses in the same directions must be T. Okay, again the bus traveled a distance. So what is distance? See, we know formula, velocity equal to distance divided by time. Okay, so what is the distance now? Velocity into time. Is that clear? So again the bus traveled a distance V into T in time t, which is also equal to the distance traveled by the man in 18 minutes. Is that clear? Right? So v into t is the distance, is equal to 20 is the velocity, the speed of the person, into 18 divided by 60, the time taken. Okay, right. So what is t? 20 divided by v we calculated just before as 40 km per hour. So 20 divided by 40 into 18 divided by 60. Okay, so what is the time period? 9 minutes. Is that clear? So this 9 minutes is nothing but the time period t of the bus service. Is that clear? This is your next question, students. A player throws a ball upwards with an initial speed of 29.4 meter per second. Okay, so what is the initial speed? 29.4 meter per second. So what is your questions? Look at here. So subdivision A, what is the direction of acceleration during the upward motion of the ball? Okay, what is the direction of acceleration during upward motion of the ball? All right, so look at the diagram. A player is throwing a ball in upwards with the initial speed of 29.4 meter per second, right? So what is the direction of acceleration? Okay, so the ball is vertically acceleration, gravitational acceleration always towards downwards direction, right? So this is direction of acceleration. Then what is the velocity and acceleration of the ball at the highest point of its motion, right? So what is the velocity at the highest point? I told you, we discussed about this in the previous video class, right? So while reaching at the topmost position, the velocity will becomes 0. Okay, so at the highest point, velocity of the ball is 0, but acceleration g will be 9.8 meter per second. Okay, meter per second squared in vertically downwards direction. See, this is how the velocity and acceleration will be. Right. Then look at the third subdivision. Choose x is equal to 0 meters and time equal to 0 seconds to be the location and time of the ball at its highest point, vertically downwards direction, to be the positive direction of x-axis, and give the sign of position, velocity and acceleration of the ball during its upward and downward motion. What is the sign? Okay, so whether it is positive or negative. So we need to give the signs of the position, velocity and acceleration of the ball during its upward and downward motion, right? So if we consider the highest point of the ball motion as x equal to 0 meters and t equal to 0 seconds and vertically downwards direction to be positive and direction of x-axis, then during upward motion of the ball before reaching the highest point position, okay, so the distance will be positive, velocity will be negative and acceleration is g will be positive. And during downward motion of the ball after reaching the highest point, right, a equal to g, all the three quantities are positive. Okay, right. Then look at the last subdivision. To what height does the ball rise and after how long does the ball return to the player's hand? Take g as 9.8 meter per second squared. Neglect air resistance. Okay, so what is the question? To what height? So height we need to calculate, and after how long, time is also we need to calculate, right? So during upward motion, so what is u? It is, we are throwing, the player is throwing the ball in upward direction which is against the gravity. So take u as minus sign. So direction is minus, u equal to minus 29.4 meter per second and acceleration is 9.8 meter per second squared and final velocity will be 0. Okay, then you can calculate s with this third equation, v squared minus u squared equal to 2as. Okay, so use this formula, find what is s. So s equal to minus 44.1 meters. So this is your displacement. Okay, right. So minus 44.1 meters. Then what is the time taken? Use the first equation, v equal to u plus at. Okay, so by using this formula you can find what is the time taken. Okay, so B will be 0 and U will be minus 29.4 and A is 9.8 and you can calculate T. So T is 3 seconds for reaching the top position, and again if this ball have to reach the player's hand, so 3 plus 3 is 6. So this is your total time taken. Is that clear? Next question, students. A ball is dropped from a height of 90 meters on a floor. At each collision with the floor, the ball loses 1/10 of its speed. Okay, so what is the height? 90 meters. Okay, right. So after each collision with the ground, okay, so this is the collision with the ground. So after each collision, the ball loses 1/10 of its speed. Plot the speed time graph of its motion between time equal to 0 seconds to 12 seconds. Okay, right. So we'll see U is 0. Initial velocity is 0 because it rises to some particular height. Okay, so before dropping, it won't have any velocity, so initial velocity will be 0. And acceleration 10 meter per second squared. See, generally what is the value of G? G is equal to 9.8. Okay, so for my convenience, I'm taking this 9.8 meter per second squared as 10. Okay, some round off value, 10 meter per second squared. And what is the distance? 90 meters. Height is 90 meters, and we need to calculate what is the time period and the final velocity, isn't it? So use the third equation, v squared minus u squared equal to 2as formula. Substitute all those given value. Okay, you can calculate what is the final velocity. V will be 30 root 2 meter per second. Okay, so this is your final velocity. And what is the time taken? This is your next thing we need to find, right? So use your second formula, second equation of motion, S equal to ut plus half at squared, right? So S is given, u initial velocity is 0 and time period half into a, in place of a substitute 10 and then t squared. Okay, so what is t? 3 root 2 seconds. Final velocity is 30 root 2 meter per second and time period is 3 root 2 seconds. Okay, so then we should find what is the rebound velocity. Okay, after striking at the ground, okay, so it will lose some 1/10 of the speed as per the question, right? So it is rebounding to some particular height. So what is that velocity? Rebound velocity. So 9 by 10. So it loses 1/10 of its speed, right? So 9 by 10, it loses 1/10 of the, okay, I'll write here, 1/10 of the speed. Okay, right? So what will be the remaining thing? 9 by 10, isn't it? So 9 by 10 into 30 root 2. This is your final velocity. So what will be the new rebound velocity? This is not root 2. This is 27 root 2. 27 root 2. 27 root 2 meter per second. See, this is your rebound velocity. Is that clear? Right? And time taken to reach highest point. What is the time taken to reach the highest point? H1. Right? So what is the initial height? 90 meters. So after rebounding, rebound velocity. So with the rebound velocity, what is the new height? New highest point. So 27 root 2 divided by 10. So how we found? We know the formula. V equal to U plus GT. So we know what is U. U is 0. Initial velocity is 0 as per the question. So V equal to GT. So what is your T? V by G. So new velocity is 27 root 2 and G is 10. So 2.7 root 2. This is your time taken to reach highest point, H1. Okay. So what is the total time taken? 3 root 2 plus 27 root 2 will be equal to 5.7 root 2 seconds. This is your total time, right? So look at the graph. This is your speed and time graph. Speed in y-axis, time in x-axis, right? So OA represents the vertically downward motion. You may think why it is in inverse manner. Okay, so this is your two-dimensional graph, right? So this OA direction, OA from point O to A, will gives you the vertically downward motion after the ball has been dropped. Okay, from 90 meters height. See this path from HO to first while it strikes the ground. This is your OA. OA represents vertically downward motion after the ball has been dropped from the height 90 meters. The ball reaches the floor with the velocity of 30 root 2 meter per second after having been in motion for 3 root 2 seconds, right? The vertical straight portion AB, see this part, AB represents from point A to B. This AB represents the loss of 1/10 of speed. The loss of 1/10 of speed. Okay. So this is also as per your question. The ball loses 1/10 of its speed. Is that clear? See, this is not 10. This is 1. Take this velocity as 1. So 1 minus 1 by 10 is equal to 9 by 10. Okay. Fine. So after loses 1/10 of the speed, this portion represented by AB. Okay, and then BC represents the vertically upward motion. See again, BC represents from point B to C. Again, it represents upward motion after first rebound from, see this point, from this point to this point. Okay, so this portion, vertically upward motion after first rebound. The ball reaches the highest point 27 root 2. Okay, right. So 2.7, this is not 27, 27.22 seconds. See, we are talking about the time period. Okay, so what is the total time from the beginning? 3 root 2 plus 2.7 root 2 is 5.7 root 2 seconds. So this is the total time from the beginning. And C represents the highest point reached after first rebound. See, this C point is the highest point reached after first rebound. See, I have given in the diagram for reference. I have given this diagram. See, this H1 is nothing but C. Okay, right. And CD represents the vertically downward motion. So from after reaching some height, it is reaching again towards ground. It is moving towards ground. Okay, so this downward motion, vertically downward motion, represented by CD. And D represents the situation when the ball again reaches the floor. So this point is D. Okay, right. And DE represents the loss of speed. DE again represents the loss of 1/10 of the speed. Okay, it will go on like that. Okay, so A, B, see, take, we'll compare these two diagrams. I hope you understood this question, but anyway, we'll see. Okay, so take this initial position as O and this position as A. So OA, this is given in the graph. Okay, so this is vertically downward motion. Okay, right. And then A to B, this is your first rebounds. Okay, so from A to B represents the loss of speed, 1/10 of the speed. And then B to C represents a vertically upward motion. So after striking the ground, take this portion as B and this portion as C, vertically upward motion. Okay, and then C represents the highest point after first rebound, and C to D represents a vertically downward motion, and D represents the situation when the ball again reaches the floor, and DE represents the loss of speed. Okay. I hope you understand this question. We'll look at the second question. Next question. Next question. A man walks on a straight road from his home to market 2.5 kilometer away with a speed of 5 kilometer per hour. So, man walks on the straight road from his home to market, which is 2.5 kilometer away. So, what is the speed? 5 kilometer per hour. So, distance between the home and market is 2.5 kilometer and he is moving with 5 kilometer per hour speed. And finding the market closed, he instantly turns and walks back home with the speed of 7.5 kilometer per hour. So he's walking with 7.5 kilometer per hour. Okay. Right. So this is the returning speed, 7.5 kilometer per hour. What is the magnitude of average velocity and average speed of the man over the interval of time? So they have given many interval of time. We need to calculate what is the average speed of a man. Okay, shall we? So first subdivision is 0 to 30 minutes, second is 0 to 50 minutes, and third is 0 to 40 minutes. We need to calculate what is the average speed of the man, right? So before that, we'll go. Time taken by man to go from his home to market is, so first we'll find what is the time. So distance is given 2.5 kilometer and speed is given 5 kilometer per hour. So 1 by 2 hour. Okay. So in 1 by 2 hour, he will reach market. And time taken by the man to go from market to his home. Okay. So returning speed, we'll see. T2, we'll take this time as T2. So again the distance will be 2.5 kilometer and what is his speed? 7.5 kilometer per hour. So 1 by 3 hour, right? Fine. So what is the total time taken? T1 plus T2, 1 by 2 plus 1 by 3, 5 by 6 hours or 15 minutes. Okay. So this is the total time taken by him. Then, so we'll find what is the average speed of the man. Okay. So in the case of 0 to 30 minutes, so what is the average velocity? Displacement divided by time. So average velocity will be displacement divided by time. So what is the displacement? 2.5, right? 2.5 kilometer away. So 2.5 is the displacement and time taken is 1 by 2. So which will give you 5 kilometer per hour. And what is the average speed? Distance by time. Again, this case also you will find 5 kilometer per hour. And in the case of 0 to 50 minutes, what is the total distance traveled? So 2.5 plus 2.5 is 5 kilometer. So this is the total distance. Then what will be the total displacement? Okay, so displacement will be 0, isn't it? So this is the distance, this is your difference between distance and displacement. Okay, fine. And average velocity for this case, displacement divided by time. What is average velocity? 0. Average speed, distance by time, 6 kilometer per hour. Is that clear? And we'll see the third subdivision, 0 to 40 minutes. Distance moved in 30 minutes from home to market is 2.5 kilometer. Distance moved in 10 minutes from market to home with a speed of 7.5 kilometer per hour will be. So what is the distance? 7.5 into 10 by 60 is equal to 1.25 kilometer. So the displacement will be 2.5 minus 1.25 is equal to 1.25 kilometer. Okay, then the distance traveled will be 2.5 plus 1.25 equal to 3.75 kilometer. So we found what is the displacement and distance traveled for this 0 to 40 minutes case. And what is the average velocity? Displacement divided by time taken. So displacement will be 1.25 for this case and the time taken will be 40 divided by 60. So answer will be 1.875 kilometer per hour. And what will be the average speed? 3.75. This is your distance. Okay. So 3.75 divided by 40 divided by 60 is equal to 5.625 kilometer per hour. So what we found? We found what is the average velocity and average speed of the man over the given intervals 0 to 30 minutes, 0 to 50 minutes and 0 to 40 minutes. Next question, students. A police van moving on a highway with the speed of 30 km per hour. So speed of the police van is 30 km per hour. Fires a bullet at a thief's car speeding away in the same direction with a speed of 192 km per hour. Right? So two things they have given. If the muzzle speed of the bullet is 150 meter per second, with what speed does the bullet hit thief's car? And note is also given, obtain the speed which is relevant for damaging the thief's car. Okay, so two things they have given, speed of the police van and the speed of thief's car. So we need to convert this kilometer per hour data into meter per second. Okay, we need to maintain in a same thing, meter per second. So 25 by 3, 160 by 3. So these two are speed of the police van and the speed of thief's car. Right, and speed of the bullet will be V suffix B. So this speed of the bullet will be the combination of these two things, speed of police van and the speed with which bullet is actually fired. So combination of these two is speed of bullet. So VB is equal to 25 by 3 plus 150. So the speed of the bullet will be 475 by 3 meter per second. Okay, and relative speed of bullet with respect to thief's car. So what is the relative velocity? VBT, bullet with respect to thief, right? So VBT equal to VB minus VT. Why it is so? VB minus VT. See, bullet as well as the thief car, both are traveling in a same direction, right? So if both the things are traveling in the same direction, what will be the relative velocity? Yes, you are right. The difference between the two velocities, VB minus VT. So 475 by 3 minus 160 by 3 is equal to 105 meter per second. Okay, so this is the speed with the bullet hit the thief's car, 105 meter per second. Students, with this your NCERT solutions over. In my next video, I'll discuss motion equation by using calculus method. And we have introduced a new term, I think you may remember about it, instantaneous speed, instantaneous velocity and acceleration, right? So we'll solve some numericals based on this differential calculus and integral calculus method, right? Thank you, students.